All right, these problems are coming straight from the textbook, end of chapter homework problems. I'm going to do the odd number problems as examples to help you complete your APLIA homework. So chapter 1, odd number problem number 1. A researcher is investigating the effectiveness of a treatment for adolescent boys who are taking medication for depression. A group of 30 boys is selected, and half receive the new treatment in addition to their medication, and the other half continue to take their medication without any treatment. For this study, identify the population, and B says identify the sample. So from our reading, we recognize that a population is a large group of individuals. So we can think of, this idea of, this represents all boys. Okay, so again, all adolescent boys, to be more precise, that suffer from depression. And of the entire population, all boys equals the population. Okay, we're going to select a smaller group, a group of 30. So if we think of population is denoted by capital N, if we take a subset where n is equal to 30, that represents the sample. So in other words, the sample will always be a smaller subset of the larger population. So again, the population, all boys, that have depression. As you can imagine, that population is most likely quite large, and therefore for us to conduct a reasonable study, we'd want a representative sample, a smaller subset. So the sample is the 30 boys receiving treatment. Okay, all right, let's go on to the next one. Statistical methods are classified into two major categories, descriptive and inferential. Describe the general purpose for the statistical methods of each category. So we can think of descriptive versus inferential. So descriptive statistics are used to organize data. So we're going to collect raw data, and it's going to be very random, hard to see any distinct patterns until we organize the information. And we can organize it using frequency distributions, tables, graphs. Again, as you can see, all of these things help to describe the information that we've collected. In some cases, most individuals don't want all of the data. We'd rather a summation or a summary of that information. So under the descriptive category, we also have what we refer to as summarizing data. Okay, or a summation of the data. And the statistics that we tend to use to summarize include measures of central tendency. This is actually chapter 3 of the text. So measures of central tendency include things such as the mean, the median, and the mode. All, I'm sure, terms that you are familiar with. So instead of giving us all of the information of frequency distribution in a table or a graph, we're going to summarize all of the data using one of these statistics, the average height of males, the average GPA in the class. Again, we don't want the list of all GPAs, we don't want a list of all male heights, we just want one value. So Measures of central tendency tend to summarize using one statistic. Another summation statistic is, or would include, measures of variability. And those include the range of scores, the variance, and standard deviation. Okay? Essentially, the descriptive statistics will fall into chapters 1 through 4. And again, it's just helping us to take the data that we've collected and present it in a way that it tells a story. Inferential statistics is the next step. To infer means to draw conclusions based on evidence or data. Okay, so this is where conducting a study would take place, where again we can't collect all data from a population. We would use a sample to test out a new drug. As in the previous item, we looked at 30 boys. Some got treatment, some didn't. And then based on the effectiveness of the treatment, we can then draw conclusions about the effectiveness of the drug. So again, inferential statistics lead us into drawing conclusions using data collected from samples. So we're using samples to draw conclusions about populations. So I'm going to write that as well. We use sample to draw conclusions about populations. Okay, and that's essentially what we need to know when differentiating between descriptive and inferential. Inferential statistics will be introduced beginning chapter 5 and take us through the end of the semester, so 5 through 12, in addition to chapter 14, so including z-scores, the normal curve, hypothesis testing, analysis of variance, ANOVA, correlation, and regression. Okay, so next question. Describe the data for a correlational research study. Explain how these data are different from the data obtained in non-experimental studies, which also evaluate the relationships between two variables. So correlational studies, a perfect example of correlation study would be the relationship between height and weight. Okay, so if we look at the two variables, height and weight. Theoretically, we know that as height increases, weight increases. And I say theoretically simply because we know some individuals that are very, very tall but rail thin, and some individuals who are height challenged and very heavy. But theoretically, as height increases, the weight would also increase, but there is no causal relationship. In other words, your weight does not cause your height doesn't cause your weight. So when we're doing correlational study, what's important to know is that we're collecting data from one group. From one group. Okay, and so for example, if we had 20 individuals, and let's say it's a sample n equal to 20, they would each give us their x variable, their height, and their y variable, their weight. Okay, so again, it's one group and we're collecting two pieces of information, two variables. Note that there is not a true independent variable here because a true independent variable is related to a causal relationship where one causes the dependent variable or outcome. So for instance, the drug is the independent variable, the amount of depression is the dependent variable. So the amount of depression depends on how much drug is administered in terms of milligrams or if they get a drug at all. Whereas here we don't say that one variable causes the other. So in a correlational study we have the absence of a true independent variable. Now from our reading we know that experimental research leads us to talk in terms of causal relationships, but we also learned about non-experimental studies where we're using something like a quasi-independent variable. So again, if we're talking about non-experimental, this one I should put here, correlation. Okay, so non-experimental requires two groups, but those groups are created via quasi-independent variable. A very perfect example, ideal example would be males versus females. So we have the construction of two groups, whereas correlation studies, one group. So we have two groups and we collect information on one variable. Okay, so the two groups are created by a quasi-independent variable. Independent variable. Okay, so again, example would be males versus females. Let me erase that for a second. Oops. Okay, so again, notice the difference. This is one group in our correlational study, and we have at minimum two groups in our non-experimental study, and those groups are constructed using a quasi-independent variable. And we then collect data on dependent variable. Let's say in this case we're looking at the difference of GPA between males and females. Okay, again, we could not say that your gender causes your GPA, right? But we could still look at the differences between males and females. Let's say we're interested in a particular major, engineering. Look at the difference between males and females. Those are the two different groups, and the data that we're collecting is the GPA that each individual has attained. So their GPA would be denoted, and we could make comparisons. So again, we could have males, females, and let's say our first male had a 3.0 and our first female had a 3.5 and 2.8 and 2.6 and 3.5 and 3.1. Okay, so again, two groups, and each of those individuals in each group gives us one data point, which is the dependent variable. So again, the distinction, correlational studies have one group. We're collecting data on two different variables. Think of X and Y, your height and your weight. Non-experimental research requires that you have 2 or more groups, and the data that were collected is derived from the dependent variable. Okay, so you want to compare 2 different groups. You could also be comparing before and after type of data. So again, the construction of those groups, those in the before and those in the after, cannot be dictated by the researcher. I can't assign someone into the after group if they haven't collected data or been part of the before group. Similarly, I can't randomly assign individuals to the male or female group. You go into the male group if you're male, you go into the female group if you're female. So random assignment into groups is what a true experiment requires, in addition to a true independent variable. Okay, so let's move on to the next one. Okay, so we have a research that found that workers who, or a worker who has some input into their design of their office space are more productive and had a higher well-being compared to workers where their office design was completely controlled by an office manager. For this study, I identify the independent and dependent variable. So in this case, we want to identify what has an effect on what. And so in this case, we are considering the effect of the individual designing their office space versus their manager. So office design. Okay, and we're either going to say self or manager. Okay, that's one variable. The other variable is actually clumped into 2 things. So we are talking about productivity and well-being. Okay. So I identified these 2 things first. Like, what are we talking about? What is the relationship that we're interested in? Then, to be able to identify which is the independent and dependent variable, we should ask ourselves, what has an effect on what? Would one say that productivity and well-being has an effect on your office design, or does the office design have an effect on productivity and well-being? Well, in this case, what we want to study is the effects of the individual designing their office versus the manager. Manager. All right, so this is the independent variable. All right, and it has 2 levels. Either you yourself design your office space versus the manager. And then productivity and well-being, right, would be considered the dependent variable. Okay, so again, what is the effect of who has control over the design of your office space on how productive you are and how good you feel? You know, what is your state of well-being? Okay, so again, try to think of this idea of what has an effect on what, and talk it through so that you can better understand what is it that we're manipulating and what is it that we're collecting data on. So again, here in this case, if this was a true experiment, we would break individuals into a category where, let's say we have 20 individuals total, and 10 of them design their own space. The other 10 have their managers design their space. And during, let's say, a 6-month period of time, we measure their productivity and their well-being. Again, these variables would need to be operationalized, which means that we would have to find a way of measuring productivity as well as well-being. So there are many measures, scales of measurement that we could use to do that. All right, let's move on to the next one. All right, 2 researchers are both interested in determining whether large doses of vitamin C can help prevent the common cold. Each obtains a sample of N is equal to 20 college students. The first researcher interviews each student to determine whether they routinely take a vitamin C supplement. The researcher then records the number of colds and each individual gets during the winter. In this, is this an experimental or non-experimental study? All right, well, what we need to ask ourselves, again, the determination is this experimental or non-experimental? So experimental requires a true independent variable that we manipulate. It also requires our ability to randomly assign individuals into multiple groups. Non-experimental study means that we don't have a true independent variable, and it can fall into one of two categories. It could be the correlational study, where we're collecting data on one group, or it can be non-experimental, meaning that the groups are defined by a quasi-independent variable. So I think the first thing that we should do is ask ourselves, how many groups are we working with? Okay, well, we know that our sample size is equal to 20. Did they divide those 20 individuals up? According to this text, it doesn't appear so. We just have one group of 20 students. Okay, and we then interview, right? It says that we interview those 20 students, and they tell us the number of colds, right, that they've received or endured during the winter. So the fact that we are working with one group tells us that this could not be an experiment. An experiment requires at minimum two groups. Okay, so that's how we can make the distinction. So this is an example of a non-experimental study. In particular, it is Okay, I'm actually going to backtrack a little bit on that part, simply because I want to save the next question for what I was going to say. So again, given that we're just working with one group and we're looking at collecting information from one group, that tells us we're working with non-experimental study. All right, let's move on to the next one. So contrary to what we saw in the last one, two researchers are both interested in determining whether large doses of vitamin C can help prevent the common cold. Each obtains a sample of 20 college students. Again, we're working with the same information. But in this case, the second researcher separates the groups into roughly equivalent groups, or students, I should say. So again, that's key. We have two groups. Let's say we have N1 is equal to 10, and then N2 is equal to 10. So we have a total of N equals 20 total. Okay, so again, the fact that we have two groups already tells us that we're working with an experimental group. Let's see what we do with those groups. The students in one group are given a daily multivitamin containing a large dose of vitamin C. So they get the daily vitamin with vitamin C. Okay, and then the other group gets a multivitamin with no vitamin C. So they get a daily with no vitamin C. Okay, so again, we see that we have the construction of two groups. The researcher has the ability to randomly assign those 20 individuals into these two different groups. We've identified how the two groups differ from each other. One vitamin C group, one without vitamin C. And then what we can conclude at this point is that the independent variable is the multivitamin. Okay, and it has two levels, with vitamin C and without vitamin C. Okay, so those are our two groups. And we want to measure the effects on the dependent variable. The dependent variable, in this case, number of colds. Okay, so again, we have two groups. We randomly assign individuals into either group, and then we collect data on the number of colds to see if the group with the vitamin C had fewer colds than the group that received the multivitamin without vitamin C. All right, so we've been able to determine that this is an experiment, right, versus non-experiment. And the reason, again, is that we're working with two groups. We have a true independent variable, right, and that individuals are randomly assigned to different groups, and we are collecting data on a dependent variable. Okay, next one. Researcher study reports that alcohol consumption is significantly higher for students at a state university than for students at a religious college. Is this study an example, sorry for the typo, it should be an example of an experiment? Explain why or why not. Okay, so again, is this an experiment? And I know that this point could be a little confusing because under the category of experiment, we have non-experimental experiment, which is kind of odd. But again, that category is reserved for studies where you have multiple groups, but those groups are constructed using a quasi-independent variable. Again, a quasi-independent variable functions like an independent variable where it constructs different levels or groups, but we can't randomly assign individuals into those categories. So again, let's talk about how many groups we have. Okay, so we're looking at a university for students at a religious college, right, versus a state university. So we have the state university versus the religious. Okay, so we have group 1 and group 2. So immediately we know this is not a correlational study, but now we need to determine, is this a true experiment or is it non-experimental? Again, the fact that we have two groups, right, fits us into the category of experiment, but is it a true experiment? And the way to answer this is to ask ourselves, can I randomly assign individuals into these different categories? And the answer would be no, I can't send someone to the state university or the religious university. We're just going to each of these campuses and collecting data. Okay, so what we were interested in is the amount of alcohol that they consume. So, you know, we would have the state data and then the religious. Okay, and then maybe our first individual at the state school says, you know, 3 drinks per week, 5 drinks per week, 0 drinks per week. And the religious school, the first student says 1 drink per week. The next student says 0 drinks per week. The next person says 0 drinks per week. So again, this is the dependent data, and the quasi-independent variable will be the type of school that they attend. So again, even though we have two groups, we recognize that it's not a correlational study, but it is an example of non-experimental research. Research, because we have two groups, right? No true independent variable that can be manipulated. So again, I can't randomly assign the college students that I'm talking to into these different categories. They go to this university that they've selected, and I'm just collecting data from them. Okay, so again, ask yourself, how many groups are you working with? Are those groups constructed by the researcher, and is the researcher able to randomly assign individuals into these categories? Or are you working with multiple groups and those groups are identified or defined by a quasi-independent variable, as in this case? All right, for each of the following, determine whether the variable being measured is discrete or continuous, and explain your answer. So from our reading, we've learned the difference between discrete and continuous. Discrete can be thought of as categorical. It cannot be cut up into smaller portions, whereas continuous is normally we think of a number line where there are opportunities to describe something as a fraction or decimal or proportion of the whole. So knowing these two distinctions will help us look at variables and make the determination if we're working with continuous versus discrete. Okay, so let's take the first one. Social networking, number of daily minutes on Facebook. So again, we want to measure the amount of time that they're accessing Facebook or are engaging in social network activities. So the fact that we're working with minutes, okay, it's a numeric scale, and we know that minutes can be broken into smaller portions. Okay, so given that, we know that we are working with a continuous variable. And in fact, we know that time, right? Time can be expressed as a fraction. Okay. The next one, we are looking at family size, number of siblings. So we look at a family and identify how many siblings exist in that particular family. It is a numeric value. So for instance, one family, there are 5 siblings. Another family, there are 2 siblings. In another family, there are 0 siblings, an only child situation. So again, it is a numeric value, but we are prohibited from expressing that as a proportion. So again, family size, number of siblings. We're counting human beings, individuals. So it would be a discrete variable. Number of individuals cannot be expressed as a fraction or proportion. And I know that some of you are thinking about recent data that says the average home has 2.5 children, okay, which is very common, a statistic that we'll often see. But what I want to point out is that that statistic is an average, okay, and averages are continuous variables, okay, so if we're expressing something as an average, that would be continuous. If we're expressing something as counting heads, it would be discrete, okay, so always take into consideration if we're working with, whole categories or fractions of a category. Averages would enable us to do fractions. Okay, preference between digital or analog watch. Something my boys have recently gotten into. They have a debate on which type of watch they want as young boys. So again, we go back to our categories, discrete or continuous. These are named categories. It's not numeric, so this one's quite easy once you recognize that you're working with word categories, that it doesn't allow you to even think of continuous as an option. So because it's named categories, we're working with named categories, right? Digital or analog. in named categories equals discrete. Okay. Next one, number of correct answers on a statistic quiz. Well, again, answering this one is really contingent upon did we get partial credit, but we will assume that the instructor is not giving partial credit, or expressing the final quiz score as a percentage. So again, number of correct answers. Okay, so similar to what we saw on family side, let's say the quiz, 10-point quiz with 10 questions. Okay, so the fact that, we just want to report the number of correct answers. If someone got 8 out of 10, in this format, it would be a discrete variable. It is the number, the actual number that they got correct. Now again, if you wanted to express that as a decimal or percentage, 8 out of 10, or if they got 80% or 0.8, that would be continuous. So note the distinction. If they're expressing as percentage or proportion, it would be continuous. If they just want the actual number or the whole number, then in this case it would be a discrete variable. Okay, let's go on to the next one. In an experiment examining the effects of Tai Chi, excuse the typo, on arthritis pain, Callahan selected a large sample of individuals with doctor-diagnosed arthritis. Half of the participants immediately began a Tai Chi course, and the other half, the control group, waited 8 weeks before beginning the program. At the end of 8 weeks, the individuals who had experienced Tai Chi had less arthritis pain than those who had not participated in the course. Identify the independent and the dependent variable. What has an effect on what? What are we hoping to minimize or diminish? In this case, it's the arthritis pain. That's the dependent variable. And how are we going to decrease it? Well, we're going to expose them to this exercise program, in particular Tai Chi. Okay. So the levels of the independent variable, so again, that's the independent. Oops. Okay, so they're going to immediately begin, or wait 8 weeks. So again, we know we're working with experiment because we have a true independent variable, and we're allocating individuals into these different categories. Those who get the Tai Chi program immediately, and then those who have to wait 8 weeks. And then we're going to measure how that program, the Tai Chi program, affected their arthritis pain. What scale of measurement is used for the independent variable? So again, the independent variable equals Tai Chi. Okay, or scales of measurement, nominal, ordinal, interval, and ratio. So again, it has these different categories: immediately or wait 8 weeks. Let's talk about what nominal is. Categorical values, so named categories. So Tai Chi, you get it now, you get it later. Named categories. Ordinal, we rank them in terms of one is better than the other or more valued than the other. At this point, we can't make that judgment. We can't say that Tai Chi is better than no Tai Chi. We don't know the results. So at this point, we cannot rank these different categories. I know some of you may be thinking, well, 8 weeks later is ranked, but we can just think of, I should be more specific here, or this may help. Tai Chi, no Tai Chi. Okay, so maybe that helps make the distinction a little clearer. So these are just named categories, so it can't be ordinal. If it can't be ordinal, then most likely it can't be interval. Interval requires some numeric value, equal increments in between categories. Ratio requires a meaningful zero where we can make ratio comparisons. So we stop dead in our tracks at nominal scale. Okay, identify the dependent variable of this study. So I think, let's see here, I've already done that, I'm sorry, I just noticed that I was a little ahead of myself. The dependent variable is the arthritis pain. Okay, and this one takes a little bit more thought to determine, or what kind of scale of measurement we're working with. But what we should hone in on is in this last sentence here. At the end of 8 weeks, individuals who had experienced Tai Chi had less arthritis pain than those who had not participated in the course. So given that we are given this terminology of less pain, less arthritis pain, so I'll write that here, less pain, right, gives us a sense of rank, right? So let's begin with nominal. Name categories. We may identify individuals as no change in pain, less pain, more pain. Right? These are all named categories to identify the effects of Tai Chi on the dependent variable. And again, because we have named categories, we know it falls into a nominal scale of measurement. But if we go to the next level, ordinal requires that we have ranked categories. And of course, in this case, we would. The fact that we say less implies that someone had more or that someone had no change. Okay, so we definitely know it's ordinal. Let's ask ourselves, is it interval? Well, we can't really say that there are equal increments in between these categories. So that prohibits us from identifying this as interval or an interval scale of measurement. Nor do we see numeric values attached, which would be required with the ratio scale of measurement, which also would require us to have a meaningful zero. So in this case, we know we're working with ordinal scale because of the fact that they identified this keyword of less arthritis. Had they said those who experienced Tai Chi had 3 fewer episodes of arthritis pain than those who did not attend the Tai Chi class. In that case, we're using numeric value to express the dependent variable, and we're making these ratio comparisons. So they had 3 episodes less than the other group, or something of that nature. In that case, we would be talking about a ratio scale of measurement, or if someone were to say they had 0 episodes of arthritis pain. We couldn't certainly have -1 episodes of arthritis pain. So in that case, it would be a ratio scale of measurement. So you have to talk this through and think about the possibilities and identify the scale of measurement based on what you are, how you are obtaining this data, how you're categorizing it. All right, let's move on to the next one. Researchers found that motivational signs were effective in increasing physical activity at a college campus. Signs such as step up to a healthier lifestyle, an average person burns 10 calories a minute walking up the stairs, were posted by the elevators and stairs in the college building. Students and faculty increased their use of stairs during the times that signs were posted compared to times when there were no signs. Identify the independent and dependent variable and then the scale of measurement being used. All right, so in this case, what has an effect on what? What are they measuring in the end, the outcome? So they increased their use of stairs during times that the signs were posted compared to the times when there were no signs. So we would say that the presence of the signs, all right, motivational signs. Okay, whether they were present or not could be thought of as either yes or no, right? Yes or no. They were present, they were not present. And this is the independent variable. That's what we're manipulating. And then we're going to measure their physical activity. That's the dependent variable. Okay. How does posting a motivational sign, such as step up to a healthier lifestyle, or the phrase, an average person burns 10 calories a minute walking up the stairs, how does that information motivate individuals to increase their physical activity? So the researcher is interested in the presence of those motivational signs, right, versus the absence of those signs. So again, we have a true experiment. We're going to measure physical activity when the signs are present. We're going to measure physical activity when the signs are not present. Okay, so we've identified the independent and dependent variable. What scale of measurement is used for the independent variable? So the independent variable, we said pretty much either the signs are present or they're not present. Yes, the signs are there. No, the signs are not. Okay. Again, absent of any numeric value, so we can automatically eliminate ratio and interval scales of measurement. Now let's talk about nominal and ordinal. Nominal says named categories. Okay, yes, the signs are present. No, the signs are not present. Okay, named categories. We know it's nominal. Let's see if it's ordinal. Can we rank those categories in order? Presence of the sign versus the absence of the signs. Subjectively, we may think that the signs, given that they increase physical activity, is a good thing and better. But objectively, we can't make that distinction. It's either yes or no, and again, objectively, we can't say one scenario is better than the other. So, motivational signs, their presence, yes or no, present, not present, would indicate that we're working with a nominal scale of measurement. Okay, let's move on to the next one. Well, interesting, that's it. So I will make another video for the additional problems, the mathematical problems that you see at the end of Chapter 1. Please, if there are any mistakes in this video, don't hesitate to let me know. Sometimes doing something live is a little challenging, so I do these videos to help you better understand the material. It's good to view them before you attempt your APLIA homework problems because they are very similar to these. And of course, as always, contact me with questions or concerns. Thank you.